Okay, we're going to talk about slope and rate of change, both dealing with real-world situations. Rate of change is the relationship between two quantities or things that are changing. If one quantity depends on the other, then the following applies. We can take the change in the dependent quantity and divide it by the change in the independent quantity. That's how we can find our rate of change. We take the change in the dependent divided by the change in the independent. We can use that to model real-world situations. I can also use this in math. The way we use this in math is called slope. Slope is the number that describes the shape of a line. With slope, we use the same concept. We take m to represent the word slope for some reason. I don't know why we use m, but we use m. And that is equal to the change, which is this delta, the change in y, divided by the change in x. Okay? As you can see, these two things are very similar to the rate of change formula that we have up here. We take the change in the dependent, whereas we take the change in the y. Okay? So our dependent variable, remember variable meaning letter, our dependent variable will always be the y value, and our independent variable will always be the x value. And we take the change in that y divided by the change in that x. That's how I find my slope, and that's how it describes the shape of that line. I use that number, that quantity, whatever I get from this formula, to help me describe the shape of that line. Okay? So, we have an example of using rise over run. How do I count my slope and help me find that slope? Again, we have a line here. Let me draw my arrows. I have a line here with my arrows on the end, and I have 2 points. I just picked 2 points on this line. I want to find the slope counting rise over run. So again, my slope is the change in y over the change in x. So I need to go from this point to that point, and I'm going to count the change in the y value. So I'm going to count, going up 1, 2, 3. So I went up 3. That's my change in my y. Positive 3. And then for my x values, I count along the x-axis to count the change in x. So I count from this spot where I stopped at. I'm going to count 1, 2, 3, 4. So I went to the right 4 times. And remember, positive being to the right. So here, this was my rise over my run. It was a 3 over 4. So my slope was 3/4 for this particular line. Because both my signs were the same, I have a positive and a positive. My signs are the same, it's going to be a positive slope. Okay? So we have a positive slope when my signs are the same and I have a positive number. And we can see that, kind of see that when my x's are changing and going up, my y is also going up. So that line is going up as I look at it from left to right. Okay? But if I look at this line, it's angled a little differently. Again, I'll draw my arrows so I know that's a line. And I'm going to take this 2 points here and here. I'm going to do the same thing. I'm going to find the change in y over the change in x. Okay, my change in y.
Mr. Richardson, can I get you to come to
My change in y, I start from this point, I'm going to go up. I go up 1, 2, 3, 4. So I went up 4 that time. And then from that same spot where I stopped at, I'm going to put a +4. And from that spot, I want to get to this line on the x-axis. So I'm going to go left. 1, 2, 3, 4. So because I went left, remember on the number line, when I go left, that's decreasing, and I'm going to have a -4. So I have -4 here. Now, that's still my rise over my run. I went up 4 over to the left 4. So because that's a different sign here, I have different signs, this is going to be a negative slope. Okay? So that's using the change in y over the change in x, or it's called rise over run, to help me count and find my actual slope. I could divide this, 4 divided by -4 would give me a slope of -1. And again, because my signs were different there, that's why I have a negative, and that describes the shape of that line. Okay? But, next slide, we're going to talk about what happens if you can't go left or right or up and down. So, we're going to do the same thing. We're going to take the change in y over the change in x. For this example, we have the change in y over the change in x. If I take these 2 points, here and here, I want to find the change in y. We always start with change in y. So I'm going to count from here to that dot, from this dot to that dot. So I'll go up 1, 2, 3, 4, 5. So I went up 5. That was my change in y, up 5, over my change in x. But if I go from that dot to that dot, I've already made it. There's no need to count left or right, like I did in the previous two examples. I can't go left or right. It's been on a straight vertical line like this. So because I can't count left or right, I simply put a 0 there. As you can see, there's a 0 in the denominator. When there's a 0 in the denominator, we have no slope. That's a vertical line. Vertical lines always have no slope, because the 0 is in the denominator, and I can't divide anything. I can't divide 5 by 0, or anything by 0 for that matter. So when we have no slope or undefined, it's also known as undefined slope, it's when our 0 is the denominator. Okay? So that's how I know if it's a vertical line. This is called a vertical line. If it's vertical, then it's going to be no slope. All right? Now, if I look at this line, going sideways like this, this is a horizontal line. So what's right, horizontal? We're going to do the same thing. Change in y over the change in x. Okay? So going from this dot to this point, we're going to count our change in y. So we need to count up or down. We cannot count from here to there. There is no change. There is no vertical change. I don't need to go up. I don't need to go down to reach this dot. So there is no change in y. But if I count the change in x, I can count over 1, 2, 3, 4, 5. I can count 5 there to the right. But as you can see, 0 divided by 5 is 0. Can't divide 0 by anything. So when 0 slope is when 0 is the numerator or the top number. Here you can see 0 over 5, and that was a horizontal line. Okay? So horizontal lines, lines that go across the x-axis that are parallel to the x-axis, will always be called, or have a 0 slope. So those are two tricky ones that we don't normally see, but you need to know that when 0 is the denominator, it's called no slope or undefined slope, and when 0 is the numerator, it's just called 0 slope. Okay, so those are two important ones you need to know before moving on. And then we have one more that you need to make sure you get. We have the slope formula. Okay, the slope formula. When given 2 points or ordered pairs, use the slope formula. The slope formula, again, m is the change in y over the change in x. What that means to us when given 2 points, we have y2 minus y1, that's the change in y, divided by the x2 minus x1. Okay? So we're given 2 points, that's why we have a y2 and a y1 and an x2 and an x1. What that means to us, if we're given this example, we're given 2 ordered pairs, 2, 4, -3, -1. I want you to label those points. This is always x, y. So this is my first point, it's going to get x sub 1, y sub 1. This was my second point, or second order pair. It gets an x sub 2, y sub 2. All I do is plug these numbers after I've labeled them into this formula, the change in y over the change in x. y2 is -1 minus y1, which is 4, over x2, which is -3, minus 2, which was x1. -1 minus 4, -5, again going back to the number line, divided by -3 minus 2 is also -5. My signs are the same. It's going to be a positive slope. 5 divided by 5 is 1. So my slope between those 2 points was 1. That's how I use the slope formula, labeling my points, plugging the numbers in, determining is it positive, is it negative, and then dividing my numbers. And I got my answer of 1. We're going to do it another time. We have 2 points here, -3, 6, 2, -9. I'm going to label them. Use a red marker now. We have x1, y1, x2, and y2. Okay? We're just going to plug these into the formula we're given. y2, which is -9, minus y1, which is 6, divided by x2 minus -3. -9 minus 6 is going to give me a -15. Divided by 2 minus, my signs are the same beside each other, Okay, we got 2 plus 3, which is 5. Now I look, my signs are different. I have a negative 15 on top, positive 5 on the bottom. So it's going to be a negative number. We're going to have a negative slope because my signs are different. 15 divided by 5 is 3. So my slope here was negative 3. Simply labeling my points given, plugging them into the change of y over the change in x formula, and getting at my slope value. Remember, the slope is the number that describes the shape of that line. If I looked at both of these numbers, I could tell you this was a positive slope, going up by 1 each time. This was my negative slope. It was going down 3 times for every 1 x value. Okay? That's how you use the slope formula to help you find the actual value of the slope. Okay, in summary, talking about slope. We have 4 different lines here. Again, just talking briefly, this was undefined. This was 0 slope, the actual letters, or you can use the number 0 or just write 0. This would be a positive slope, and this would be a negative slope. Okay? And remember, slope was the change in y over the change in x. And that formula we derive from given 2 points. When we're given 2 points, we can use y2 minus y1 over x2 minus x1. Okay? All of this is what we need to know when we're solving real-world problems to help us use a linear, remember linear being line, linear relationship between 2 quantities, and helping us find that rate of change and put it into a slope formula, which we have here. Okay, so those are your notes on slope and rate of change.